NASA's James Webb Space Telescope has captured unprecedented pictures of a newly discovered exoplanet.
What if I told you NASA's most powerful space telescope just caught sight of something no one has ever seen? Something that could change the way we look at planets beyond our solar system. A distant world, hidden in the glare of its star, has finally been exposed by a feat of engineering that pushes the limits of what we thought possible. But how did they do it? And what secrets might this strange alien world be hiding? Stay tuned, because in the next few minutes, we'll uncover the bold step that could redefine our hunt for other worlds. This isn't just another space image. This is the start of something far bigger. Webb's first alien planet image. NASA's James Webb Space Telescope, JWST, has achieved a landmark breakthrough by capturing its first ever direct image of an alien planet beyond our solar system. This extraordinary discovery marks the first time Webb has visually confirmed the existence of an exoplanet, designated 207b, located about 100 to 110 light-years from Earth.
And scientists have discovered a TWA-7b was found orbiting a star 110 light-years away from Earth.
2A7b appears as a distinct point of light in Webb's powerful gaze. Unlike earlier methods of detecting exoplanets, such as tracking a star's wobble or observing the dimming of starlight as a planet passes in front, this is a direct visual confirmation.
Scientists say that the exoplanet is almost 10 times lighter than the planets that have been imagined so far.
The achievement represents a giant leap forward in our ability to not only infer, but actually see planets orbiting distant stars. The significance of this discovery for Webb's mission cannot be overstated. Since its launch, JWST has been celebrated for delivering stunning views of ancient galaxies, star nurseries, and the chemical makeup of cosmic structures billions of light-years away. However, imaging an exoplanet was always considered one of its most ambitious and challenging goals. The telescope was engineered with instruments capable of capturing faint planetary light next to the overwhelming glare of host stars, a task that requires incredible precision and sensitivity. With this success, Webb has proven that it can deliver on one of its most technically demanding promises, further solidifying its status as humanity's most advanced space observatory. This moment also has significance as a major turning point in exoplanet research. For many decades now, astronomers have discovered exoplanets indirectly, radial velocities or transits, as photometry methods to detect their presence. While these methods produced thousands of confirmed planets, they yielded a rather limited scope of what these recall worlds are really like. 2A7b is now being directly imaged and opens up the way to studying exoplanets in a new light, one where it will be possible to observe the light emitted by such planets, analyze their atmospheres, and look for the signs that they may harbor life someday. And it heralds the dawn of that era. Researchers can study other worlds not only as data points, but as observable celestial objects. It is a remarkable discovery that throws a strong contrast into Webb's earlier successes. So far, the telescope is most remembered for deep-field images capturing galaxies formed shortly after the Big Bang. It also sheds light on star formation and maps the chemicals of distant cosmic phenomena. Exoplanet imaging brings Webb's mission closer to home, focusing on distant planetary systems that yet offer significant clues for understanding how worlds can be formed and might differ in our galaxy. This further emphasizes the versatility of the telescope and how it could change our understanding of the universe at various scales. Getting a clear image was only half the battle. The real surprise lies in how Webb's hidden tools made the impossible visible. The science powering Webb's find. The discovery of 2A7b by NASA's James Webb Space Telescope was made possible through the use of cutting-edge technology, with the coronagraph at the heart of this achievement. A coronagraph is a specialized instrument designed to block out the intense light from a star, allowing much fainter objects, such as orbiting planets, to become visible. The principle is similar to how the moon can obscure the sun during a solar eclipse, revealing the sun's corona. In this case, the coronagraph created an artificial eclipse, shielding the overwhelming brightness of TBA7's star and making it possible for Webb to detect the dim light reflected off the distant exoplanet. Without this innovative tool, the light from the star would have completely drowned out the faint signal of the planet. Beyond simply blocking the starlight, sophisticated image processing techniques played a crucial role in enhancing the visibility of TWA-7b. The faint light from a planet like TWA-7b is often buried in residual glare, scattered light, and instrumental noise. To overcome this, the research team applied advanced algorithms that filtered out these distortions. They combined multiple exposures, carefully subtracted background patterns, and adjusted for optical artifacts to sharpen the image of the planet. These digital techniques amplified the signal from TWA-7b while suppressing false positives, ensuring that what appeared in Webb's data was indeed a genuine planetary object rather than a trick of the light or instrument error. The observation of a planet beyond 100 light-years away with phenomenal success proves the point of the power of Webb's advanced optics. At the heart of the telescope is the 6.5-meter segmented primary mirror, the largest ever deployed in space, gathering and focusing light like never before. That light-gathering capability, combined with sensitive detectors, allowed Webb to disentangle the faint planet light from the nearby brilliance of its host star. Meanwhile, the telescope's fine guiding system held its instruments perfectly aligned, enabling long exposures without blur, a must for detecting such a distant, low-contrast target. Webb's optical design has now proven successful not only for probing the ancient universe, but also for exploring planetary systems much closer to home. One of the greatest engineering feats for the Webb mission was to isolate the light from TWA-7b against the glare of its star. Indeed, even with a coronagraph, the scattering of light by the star can create artifacts that mimic or mask real celestial objects. Engineers designed optical elements, coatings and software capable of suppressing that scattered light to an unprecedented extent. Every single piece, from mirror segments to detectors, had to operate in almost perfect harmony. This finding is a true indicator of decades of engineering daring, showcasing Webb's ability against the very nature of exoplanet imaging, a task that demands the blocking of 1 billion times more light than that reflected by the planet. The alien world revealed. WA-7b, the exoplanet that has captured the attention of astronomers worldwide, stands out as a unique and intriguing world. This distant alien planet is comparable in size to Saturn.
The brand new exoplanet TWA-7b. Thousands of these have already been discovered, but images like this,
one of the gas giants of our own solar system. However, while it shares a similar physical diameter, TWA-7b is remarkably less massive. In fact, it is about 1/10 the mass of the smallest exoplanet ever previously imaged directly by a telescope. This combination of a large size with such low mass challenges existing models of planetary formation and structure, raising new questions about how gas giants can develop and maintain their shape and stability under such conditions. The mere fact of its physical profile makes it an exceptional find on the growing list of known exoplanets. But what makes TWA-7b even more interesting is its very juvenile condition, just about 6 million years old, and is considered a newborn in pretty much all astronomical terms. To put this into further context, our Earth is around 4.5 billion. So this means that TWA-7b is still having the first stages of existence. Such a young age implies that the planet is still undergoing processes of formation and development, which more matured planets completed long before. Observing TWA-7b offers scientists a rare opportunity to study planetary characteristics shortly after its birth, a phase usually shrouded in visibility, or one that is inferred only via indirect evidence. The youth of TWA-7b gives scientists a unique laboratory to test their theories of how planetary atmospheres evolve and how internal structures take shape during the very early periods of a planet's life. Another striking thing about TWA-7b is how far and slow its orbit is. This planet stands apart from others, maintaining its gigantic distance from the host star. For, with an orbital period bearing several hundred Earth years, a single year on TWA-7b could last several human lifetimes. This massive distance will not only permit instruments like Webb's coronagraph to do observations of planetary light free of stellar interference, but will also engender special settings concerning temperature, atmosphere, and long-term stability for the planet. Its story gets even more intriguing when you look beyond the planet itself and glimpse the restless environment it calls home, the planet's cosmic environment. The cosmic environment surrounding 2A7b offers a fascinating glimpse into the dynamic conditions of a young planetary system. Central to this environment is a narrow debris ring that encircles the system's host star. This ring consists of dust, rocky fragments, and other remnants left over from the early stages of planetary formation. Unlike the broad, diffuse belts of debris seen in some older star systems, this ring is compact and well-defined, suggesting that the processes shaping it are still actively at work. The dust within the ring swirls around the star in complex patterns, sculpted by gravitational forces and collisions between particles. This narrow band of material stands as a visible marker of the energetic, ongoing interactions that accompany the birth and growth of planetary bodies. Adding to the complexity of the system are two distinct empty gaps in the debris disk. These gaps are regions where the dust and rocky material have been cleared out, likely by the gravitational influence of planets or other massive objects moving through the disk. The structure of these gaps is telling. One is sharply defined and narrow, while the other appears broader and more diffuse. Some features suggest the presence of yet-to-be-detected planets that have shaped the environment with 2WA7b. The existence of these stands is crucial because they give direct evidence of how naive planets redefine their surroundings and clear pathways as they orbit around their star. Empty regions provide astronomers with valuable clues on mass and motion distributions within the disk. Centered within this young cosmic term is a rather young star in itself. It is believed that this star host, TWA7b, is perhaps a few million years old, which makes it a relative newborn during a lifetime of stars.
A star would behave entirely differently. They may have been huge.
Still in the relatively youthful age of the star, quite young by stellar standards, the radiation and stellar winds would still be driving effects on the surrounding disk, clearing out dust in some areas and compressing it into rings in others. The energy output of the star, in association with its gravitational pull, is influential in shaping the architecture of the debris disk. Its ongoing activity provides a rare opportunity for astronomers to see in real time the grand forces with which planetary systems are sculpted during their formative stages. Direct imaging of alien worlds. The direct imaging of 2WA7b marks a significant expansion of the James Webb Space Telescope's capabilities and firmly establishes it as a powerful tool for exoplanet discovery.
And scientists have discovered a brand new exoplanet. They say planet TWA7b.
Until now, Webb's fame has largely rested on its ability to peer deep into the universe's past, capturing stunning images of ancient galaxies and stellar nurseries. With the successful direct detection of 2WA7b, Webb has demonstrated that it is not only a window into the distant cosmos, but also a precise observer of alien worlds within our own galactic neighborhood. This proves that Webb's futuristic instruments, specifically designed for high-contrast imaging and starlight suppression, really can pick out and record the adamantine light of these exoplanets from their bright stars. Webb's coronagraph teamed with the telescope's mirrors and sensors to unveil 2WA7b, thus establishing Webb as a sorely needed telescope in the search for distant planets. This magnificent achievement advances the cause of detecting other exotic, newborn, distant planets that were previously out of reach. TWA7b is one such exotic example, a large and less dense planet orbiting far away from its star, in conditions where such planets are doubly difficult to study through any available means of older generation telescopes or indirect detection methods. While these observations may hold promise for shedding some light on how planets like Jupiter or Saturn in our own solar system might have looked in their infancy, Webb allows astronomers to direct their telescopes toward young planetary systems where new worlds might still be forming or evolving. Webb may shed some light on the really early days of planet formation, going on with stars of different environments. Another direct detection of Tyubuye 7b highlights how Webb's exoplanet work fits in with its central deep space mission. The instrument was primarily developed to consider galaxy, star, and cosmic structures, formation from the earliest eras of the universe. With its backup focus on the exoplanet, Webb proves to be amazingly versatile. In contrast to looking solely at the large-scale history of the cosmos, Webb can now focus on the minute details of the formation of planetary systems right in our galactic backyard. This unique capability, both to study the grandest scales of space-time and to pick up faint signals from an individual planet, renders Webb that much more precious of a scientific tool. Webb fills the gap between cosmology and planetary science. Unlike any previous observatory, scientists behind the discovery. The discovery of Tyubuye 7b is not just a triumph of technology, but also a shining example of international collaboration in modern space science. At the heart of this achievement is a team of researchers from France's prestigious National Centre for Scientific Research, CNRS, working in partnership with the Observatoire de Paris, PSL, and Université Grenoble-Alpes. These institutions combined their expertise in astrophysics, optics, and data analysis to lead this groundbreaking effort. The collaboration brought together specialists in exoplanet detection, instrumentation, and computational modeling, each contributing vital knowledge to the mission. The joint effort thus manifests the truism that discoveries of this order do not arise from a single organization, but instead from shared forefront research, invention, and dedication among centers of excellence. One of the prime movers behind the success of this project is Dr. Anne-Marie Lagrange, a prominent astronomer and an exoplanet imaging pioneer. As principal investigator, she was instrumental in designing the strategy that allowed the direct detection of Tyubuye 7b and brought to bear on that strategy her considerable experience in observational techniques and the interpretation of faint planetary signals. Under her leadership, the team improved the application of Webb's coronagraph, optimized data collection, and carried out careful calculations to disentangle true planetary light from background noise. This vision and expertise of Dr. Lagrange not only facilitated this discovery, but also set a high bar for future endeavors in exoplanet direct imaging. The successful discovery of Tyubuye 7b is a hallmark of how space science is becoming cosmopolitan in nature. While the research team is based in France, the work involved a far-reaching worldwide collaboration consortium working on the design and engineering of Webb instruments to data sharing with astronomers nationally and internationally. Such collaborations are important across national lines and unite scientists in a common purpose to advance human understanding. This spirit of coaction also reiterates the fact that space exploration and discovery really are the birthright of humanity working in a spirit of partnership with diverse ideas and resources from different nations. The successful discovery of Tyubuye 7b exemplifies that international collaboration is not only a good thing, but a necessity when moving the frontiers of science. Their achievement is only the beginning. What it reveals about the origins of worlds is where the real story unfolds. Redefining planet birth theories. The discovery and direct imaging of Tyubuye 7b offer a rare opportunity to refine our models of early planetary formation. Because Tyubuye 7b is only about 6 million years old, it represents a very young planet, still in the midst of its developmental stages.
The new planet is young, only about 6 million years old, and about the same mass as Saturn in our own solar system.
Observing such a planet gives astronomers valuable data about the conditions that exist during the earliest phases of a planet's life. Tyubuye 7b's unexpectedly low mass relative to its size challenges some existing theories about how gas giants accumulate material in their formative years. Examining properties of such a planet within the comparison framework of model predictions can update the concepts that scientists hold about mass, composition, and distance to orbit concerning formation processes. Thus, it would open up a clearer way to observing the giant planet formation scenario out of swirling disks consisting of gas and dust. Equally important is how this entire framework currently benefits ideas concerning the TWA7 debris disk in the context of planetary system shaping. The narrow debris ring and an empty gap in present-day TWA7 show that planets are actively sculpting within it, including probably TWA7b as well. In other words, the conditions under which the planet evolves and interacts with the disk material provide information about structure's evolution with time. Planet migration is somehow inferred from the geometry and structure of a disk, just like the redistribution of the leftover material it leaves behind. In a real-time configuration, the TWA7 system shows the process whereby forming planets clear paths, gather debris, and shepherd debris into distinct rings. These features are useful for understanding how planetary systems develop gradually, from chaotic clouds into organized architectures. TWA7b is, therefore, important in the context of understanding its own system, but also serves as a proxy system to see how perhaps solar systems like ours might have formed. Could it be the nascent condition of the solar system as indicated by TWA7, young stars' interaction with its planet disk, and a dynamic environment? The comparison of TWA7b and its surroundings with early solar system evolution models would help astronomers test theories about how gas giants like Jupiter and Saturn shape the formation of terrestrial planets, asteroid belts, and Kuiper belt objects. It creates a critical reference point by which the dots may be connected between young planetary systems in a far distant space and the ancient history of our own cosmic neighbor. If you're as amazed as we are by this discovery, don't forget to like, drop a comment with your thoughts, and subscribe for more mind-blowing space updates. And hey, don't stop here. Click on the next video on your screen to dive even deeper into the mysteries of our universe.